Okay, welcome back, everyone. It's now time for the closing panel, chaired by Derek Khlopin. Derek is Deputy Associate Administrator in NTIA's Office of Spectrum Management, or OSM. Mr. Khlopin leads spectrum management efforts for the federal agencies, NTIA coordination groups such as IRAC and PPSG, and spectrum policy initiatives. Whatever good ideas come out of ISART, Derek is going to be a linchpin of helping those ideas transition into spectrum policy and spectrum management practice. So it's great that he's able to join us today and engage in this discussion. Derek, over to you and the panel.
Thank you very much, John. I appreciate the very kind introduction. I am extremely thrilled to be able to moderate this session. This is a fun one. We get to sort of wrap up, reflect on these past 4 days, of great sessions and keynotes, and then look forward, sort of wrap up and think about, what we take from this and how we move forward. I'm excited. And an overall point I'll make here before I turn to my panelist is, I feel like we're at a bit of an inflection point in time, and I think a lot of these discussions have talked about that. We've made tremendous progress in spectrum sharing, but it sort of feels to me like we really need it feels like we need a real breakthrough or breakthroughs to take us to the next level. For example, to really enable true dynamic, real-time automated spectrum sharing. I think we've taken these steps that are, very important if you think of CBRS and others, but I think a lot of our conversations over the last few days have talked about the next big thing. And I think as we get to the second part of this panel here, I think we'll talk about how what we really need to do to get there, to envision that over the next 10 years. I think what I'd like to do here, and again, so folks understand, these are the moderators of the sessions that we've had throughout ISART. I think what I'd like to do is have moderators reflect first on the sessions that they conducted and what some of the takeaways were and the conversations, and reflect on that. And then I think we'll go back through again and try to think about looking 10 years out on where we think these communications and sharing technologies are going, or the frameworks are going, and then the steps we need to get into to start making that happen as soon as possible. Start moving in that direction. So I'm going to kick that off. I'm going to turn to first here to Eric Nelson, who is sitting in for Brian Tremont, who ran that panel. And Eric, if you want to talk about what your panel was and what some of those takeaways were.
Yeah. Thank you, Derek. So the industry panel had quite a bit of material that they covered. There were a number of recurring themes. They've had experience for well over a decade working through a lot of these problems. So it was quite valuable to have people take real objective evidence to the table and be able to speak to that. I'll just kind of walk through the things that I highlighted going through the recurring themes. The first one came up is the need for trusted agents. Trusted agents provide multiple benefits. One is they're a broker for information exchange. Information exchange came up over and over again. Both parties, both incumbents and entrants, need access to good, trustworthy data. Oftentimes that data is either sensitive or proprietary. There's oftentimes issues with the nature of that data. In some cases, like with Ambit, there's actually classified information. So one of the things, kind of pulling on that thread a little further is you really need to start that process early. If you know that you're going to have to get into a lot of depth and detail, have access to sensitive data. There's legal frameworks involved. Greg Wagner in a different panel brought that up. Data sharing isn't just a matter of sharing the data, but if it becomes a part of a policy or a rule, it oftentimes leads to data retention requirements. And so you really have to do your homework and get the lawyers involved early to make sure that you have access to that. There was talk about who should be that trusted agent. There's with Ambit, they have the I think it was the Paths program that was set up by NSC. Certainly, they have done and were highlighted as having done an excellent job in that band. But as well, NTIA, ITS, in our Office of Spectrum Management, as long as the FCC, were highlighted as critical agents in that process. I think the other thing that came up is, at those early stages, we need to properly resource both organizations, and with NTIA, so I'm a little biased in endorsing that, but obviously a good idea. There's a lot of legwork there. It's very time consuming. In our capacity as NTIA's research and engineering lab, oftentimes our core programs are about developing new capabilities. And we put that into the research needed to develop the spectrum sharing approaches and measurement systems and analysis techniques. The actual legwork of sitting down and working out the details of a spectrum sharing solution requires additional resources. So that's something that, everyone highlighted as a need to properly resource the organizations that are involved in the information sharing setup and establishing those trusted agencies early on in the process. Another thing that came up is need for regulatory certainty. But part of the conflict there is we also need to evolve. So that's kind of a conundrum there, right? If you want to change, but you don't know where those changes are going, how do you handle that? You want to establish the rules and the framework up front, but as like Needy Tandon mentioned in the panel, we don't want rulemakings occurring after an auction, for example. So I've heard over the years the metaphor of a ratchet be brought up, in that perhaps you come out, you have your best data, your best information, you have your rulemaking, and then with time, what you do is see if additional studies, measurements, and analysis can gain greater confidence in new approaches that enable increased access to spectrum while protecting the incumbent. And so the ratchet idea is unfortunately, you start conservative. You start with the best information. You start conservative with the expectation that we'll resource the kinds of studies required. So it's not just industry doing these studies, but the incumbents are involved and trusted agents are involved, so that you can do the studies and determine if you can kind of turn that ratchet and get a few more clicks out of it, so to speak, and get additional access through maybe modifications or evolutions in the approaches to sharing. And that was something that Needy highlighted. Is exploit the technology. If there's advanced antenna systems were mentioned, if we can gain more knowledge about various hooks and various features in advanced antenna systems that give us even more abilities to fine tune and tailor spectrum sharing solutions for particular incumbents, then that's something that might be exploited to grant greater access, again, while maintaining the confidence from the incumbent perspective that we're still protecting their critical services. And Needy mentioned there's with that constantly evolving system, one of the problems is and she mentioned, I took particular note of it, that their system is constantly evolving. She had mentioned that in the AWS-3 deliberations, there was what was called the randomized real deployment. And what that was kind of a real life network density kind of map that one of the carriers provided, gave the folks at Office of Spectrum Management insights into the density of the deployment so that they could do their interference modeling. She cautioned against wanting to constantly update that because it's a moving target. Clearly, if you start deploying a massive change in your network, or if perhaps you're going from a macro cell deployment to a lot of small cells, you really have to factor that in. Ironically, in the AWS-3 deployments, I had personal knowledge from this, some of the modeling for small cells treated the user equipment and being served by small cells in the same manner that users off of macro cells that might be powered up at higher powers. And so we weren't really taking advantage in that modeling of the capabilities of small cells. So perhaps you look at those major changes in the network, but you're not constantly looking at at cell counts on a monthly basis, for example. Another topic that came up is enforcement multiple times. Just about all the panelists mentioned enforcement. Bill mentioned that incumbents will build protective fortresses if they don't trust that enforcement will work, and so naturally people will start reacting to an environment if they don't have trust in the environment, and we really don't want to have that. So how do we make sure that we're building enforcement into these new rule makings and new sharing schemes up front, just like you build security in up front. Mark Gibson mentioned that there was talk about maybe the SAS could be a bounty hunter, was the term he used, and he said, well, that's not a good approach. And then Bill Davenport came back and said, well, perhaps the AFC could preemptively address issues before enforcement is even needed. So you could look at tuning the systems and making preemptive adaptive changes to the actual uses and the sharing schemes, so that you don't have to bring enforcement folks to bear on the problem. So that's a wrap up. I'll have more to say in detail as we proceed.
Thank you, Eric. That's terrific. Yeah, a lot there. Certainly, those panelists jumped all over the place, which is important with the policy implications of all this stuff. I'm going to next turn, Giulia, to you to talk about the economics panel, and again, sort of an open-ended question on some takeaways there, what some of the conversation was, and as I mentioned to the others, I think we'll then later on in the discussion sort of look forward to the next 10 years, but maybe just some of your takeaways from that session. Thanks.
Absolutely. Thanks, Derek. And sorry for being late. I apparently translated time zones wrong. So I am sort of winging this. So let me reflect. I think the best part about the economics panel was really that it was a pretty diverse panel, both in makeup, but also, frankly, in opinions, right? So, I think we kicked it off with Martin Weiss, who was talking about spectrum anarchy. So really focused at the local level at, how can we improve usage at a local level by essentially sort of lifting rules, if you will. And then we moved on to Sarah O, who had a fascinating proposal, thinking about ways that one could use STAs and essentially create a market for STAs, and not necessarily, again, I think she had on the most, sort of more than maybe thinking through the legislative challenges that might be created there. But the idea, I think there's so much, sort of this concept, and highlighting the point that there may be demand for fairly short-term usages, that one could create a market that could, in fact, sort of improve usage of the spectrum. And then we heard from, sort of taking it back to this side, from Edgar Rivas, who works for Senator Hickenlooper, really talking about some of the challenges and what they are looking for in terms of coordination, sort of what they are looking for in terms of being able to get some revenues from the spectrum, or looking for cooperation, and highlighting some of the sort of the more, I would say, sort of data-driven decision making that they are that the Hill is looking for going forward. And let's see. So let's see. Then I think Carolyn Kahn did a really nice job of an approach that I actually think we should think about, and for those of us who are sort of aware of programming, of how programming works, but sort of a more incremental approach to making rules that really sort of looks at taking rulemaking stage by stage, and how can we do a better job of improving usage that way. And then finally, Greg Roston wrapped it up talking about use it or share it, and adding that concept in. So I think it was highly diverse, a lot of different ideas, but I think the takeaways there are a number of solutions and a number of potential tools in the toolbox. And it's just a matter of sort of finding, the right tools for the right problems. So I'll leave it there and wait for more questions.
Sure, thank you, Giulia. And you're right, that is diverse, and the right tools and sort of how to prioritize amongst a lot of good ideas. I mean, that's part, a lot of the challenge sometimes, for sure. Ed, I'm going to turn to you next, and your panel on data sharing and transparency, and to talk about your takeaways there, and what some of the panelists were the highlights of the conversation. Thanks.
Fantastic, thank you very much. So the data sharing transparency panel was really trying to look at those engineering, technical, administrative, and system solutions that could help us improve the current level of data sharing and transparency. And I think, we can all probably admit that we could do better within this area, and therefore we kind of need to put a little bit of motion forward so that we can try to improve on this in the coming years. I think there were really 4 points that came out of this. And the first one was on virtualization, which I think was very exciting. So some of the panelists talked about their fantastic engineering solutions in the cloud, for how the whole telco industry is moving towards the centralization of those processing activities. And I think that that's exciting, because what we currently lack is a lack of evidence recorded, by frequency band, across space and time. And I think that this move towards that kind of centralization may provide us with a new opportunity to kind of gather that data in some sort of way. There's lots of issues here, so we're going to have the same kind of national security and privacy issues. We're going to have the same issues with the operators being worried that this is, going to reveal their competitive advantage in the marketplace for how they deploy their networks, things like this. But, if we kind of preemptively think about what may be useful to support regulatory decisions and other decisions in a few years' time, that maybe there's the opportunity to put forward now new data standards for recording that data and actually moving some of that data in aggregated form so that it's not quite as revealing to some other location where that data can be stored, essentially. And then that might be really useful for the future. And then I think, secondly, the thing that came out of the panel was actually on the fact that MOUs are already in place and data sharing is taking place. It's just that's a very long and protracted process, particularly if government has to share that data. Because that is going to involve a lot of legal review, essentially. So I think that that's something which could go on, but I do think that we don't actually have to have the true data sets shared to a certain extent for a lot of uses. Just knowing the distributional shapes and some of the underlying parameters would enable us to kind of generate our own synthetic data sets, which is kind of the third point, which I want to get to, which some of our speakers spoke on in great detail. And that's that we have the ability to generate these for people working in the spectrum science area. And that gives us an opportunity to not deal quite with the underlying real data that has those privacy and security issues, but to generate something synthetic that can be validated and be broadly correct, but which still doesn't introduce a lot of those more detailed and nuanced problems that we have when we work with spatially explicit spectrum data. And then I think just finally rounding up on my fourth point, it's that, we had this theme through the panel about spectrum data science. And I think just the fact that this is as much an art as a science is kind of worth recognizing. So we all know that we end up making assumptions, exogenous, a priori assumptions about how the world works when we build our models, and we never go back and explore the variation of those, or we rarely do. In which case, then we kind of have all of these embedded uncertainties in the results that we produce. So I think trying to move to a position where we can interrogate each other's models at greater depth would be really good for that, overcoming that, and recognizing that ultimately these are kind of discussion tools, right? We're not always going to get a model which provides us with the exact answer. I don't want to get into that metaphor, into that comment again, but all models are wrong. But ultimately, this is important for us to reflect on the fact that these are discussion tools, and that we should be able to share them and look at what we've each done, and then ultimately have a discussion around how that may affect the results. And from what I'm hearing from other people on other panels who are in government or other agencies or the private sector, they've actually said that when they sit down with other engineers and they go through all of this process, they find the common ground and they find out where the disagreement is, and then they're able to put a solution in place to overcome this. So I think that there is positivity there. Then I think the final point, just picking up on that fourth data science one, is that data needs to be turned into meaning. And if we do collect all of this wonderful data from virtualized infrastructure, then ultimately we need people to be able to turn that into something which is relevant to decision making in government and industry. So I'll turn it back to you. Thank you.
Thank you. No, that's terrific. That was a great panel session for sure. JP, going to turn to you next. I know something you spent a lot of time thinking about this, risk-informed interference analysis, a core issue as we look to solve these, intractable interference disagreements or perceived interference disagreements that have been out there forever, and we butt our heads up against that. So if you want to take it from here and talk about that session, thanks.
Thanks, Derek. Yeah, it was a wonderful experience and a great honor to actually speak with these 5 people. Rob Henry from MITRE, Omar Alcala from FDA, Callie Conson, Johns Hopkins, Nick Lesort from your office, and Kumar Balachandran from Ericsson, and they all came from very different perspectives, but they all think about risk. So in a very important way, this is a very limited view, and you can take it with that context. But I was very encouraged, and frankly, I was somewhat surprised that there was something of a consensus that the kinds of approaches that are commonly used in risk assessment, like probability, assessing likelihoods, thinking about impact, doing statistics, is like, yeah, sure, not a problem. Everybody just takes that for granted. And it was almost a non-issue, for at least for the people on this panel, that, yeah, there are these methods and we use them, whether they're in industry or whether they're in government. So the fact that it was no big deal was important, was a big deal for me. I think that there was another message which was in a way related to this, which is that communities that used to do things differently can adopt risk-based analysis. So if you look at the FDA, for example, or actually we're going to have a panelist from the Nuclear Regulatory Commission, and the person from MITRE, Rob Henry, spoke about this. There are many industries where, worst case is, or used to be, the way in which everybody operated. But if you frame the method properly by talking about the outcomes and the mission and what you're trying to achieve, rather than focusing on, risk versus worst case, the stakeholder communities come around to it. I think that there were common themes that actually we've heard from some of the other panels as well. Obviously, and you can see this in the structure of the conference, the organizers know this, this whole question about the importance of data exchange, the importance of transparency, and all the things that actually go along with that, with evidence-based approaches like peer review, like reproducibility. Those are all important things. However, they take time. A number of panelists mentioned, yep, but this takes time. And I think some of these processes are, it's like inverse dog years. It takes a lot longer for that organism to do things. They live more slowly than humans do. So institutions live more slowly than humans do. So things takes time. The other thing which I think was important was, and actually I'll pick up on a point that Ed made, a phrase that he used, which was turning data into meaning. And so when one thinks about objectives, and when you actually look at the challenges of these processes, where there are multiple stakeholders, you say, well, let's think about the impact. Well, different people worry about different impacts, and they worry about them differently, and they assess what the meaning of a result is differently. There are always going to be, and there are inevitably, conflicts and tussles. I'll leave more detailed comments about this for the forward look, but I think one of the things that struck me was that evidence-based, science-based methods only go so far. Even if everybody is a well-intentioned scientist, engineer, people will have different assumptions because they have different perspectives. They may even use the same software, but they will come to different conclusions and they will interpret the implications differently. That's a feature. It's not a bug. But in order to work with that feature, we need to have institutions where people can come together and have those conversations.
Thank you. No, that's great. Really thoughtful reaction to that panel. No question. To keep it going here, so Billy, I'll turn to you and your panel on standardization of propagation modeling. Always a challenge, but then I know that's certainly something ITS has spent a lot of years thinking about and talking about. So if you can take it from here, thanks.
Yeah, thanks, Derek. So I during the course of the panel, I kind of took away 4 key themes that, we had people from industry, government, and academia, and there was 4 kind of my takeaway ideas that we circled around. Although interestingly, sometimes I would argue we folks in different agencies talk to the same point, but from a different perspective, and I'll mention that. But the first thing was really, you really need to establish open and frank conversations. No surprise when you're dealing with engineering and technical this, but you really need that kind of open conversation, and it needs to be technically founded, right? So if once you veer off of the world from a technically based kind of conversation on these matters and just being frank about what you're trying to solve, what some of the other panels talk about, you start to see those biases and different perspectives come in. But if we can be upfront, it was mentioned that some of all the panelists had been involved in standardization and sometimes sharing scenarios in different aspects, whether international or within the US. And there's even acknowledgement that in some cases they didn't start off well, the conversations, but if they sat down, they said, we're just going to have a technical discussion, let's lay the facts out, and let's talk engineer to engineer, essentially, you can make progress. You can work the problem in that way if you keep it grounded that. And really, that kind of leads into the second thing, and a couple other the moderators talked about, is transparency. The data that you're collecting, the methods you're using, it needs to be transparent to establish that kind of trust to have those conversations, right? This was brought up by a variety of panelists, whether it's Dr. Salus bringing up the fact that, you need to, when you present data, measurement data, it needs to show everything. You need to capture system information, all the information you're capturing on the measurements to be able to present that and sort of have a discussion on that. When Dr. Riffy brought up, when you present data that's limited or shown just in brevity, that causes problems because then people have to fill in their own assumptions as to those missing pieces. And sometimes then you end up having to maybe not reject it or maybe not be able to integrate that completely into the analysis you want to do. And that's where you start to veer off. You risk veering off kind of from that, let's have a frank technical discussion, because now you have to fill in gaps. If we do things and we capture everything and we put everything on the table, that really is how you work the problem. It was brought up that you really need, and Clay brought up kind of, you need some flexibility when you start to rulemaking. This is a little bit outside standardization, but it has an impact. And that's, he brought up how, with the SAS, the models were baked into the rulemaking themselves. So when you lock yourself in from the beginning and restrict yourself, there's not a lot of places you can go, right? And this was actually brought up in a variety of different panels. Paul Tillman brought it up in the data panel about, we would do things differently in the SAS band if we did it today than we did it past. But because the rulemaking and everything was so structured, you were just limited. No matter, even if you had all the data, even if you had and understood everything that's going on, you're kind of put in some real tight guardrails at that point. And Tony brought up Tony Renier, but the fact that, you need to, as you work this with the flexibility, is don't try to tackle everything at once. Look at the problems, break them down to, what I would say small atomic units, estimate essentially their impact or their size and take one at a time and work one at a time and incrementally move the process forward. You don't need to solve the whole thing on day one. And then lastly, this is the one that I think some of the panelists really talked to a similar point, but from a different perspective as to where they were coming from. And I didn't get to see JP's panel, but I have a feeling that it crossed over into that, is the idea of taking some risk. So Andy Clegg brought up the idea that, we didn't have any interference within the 3.5, the SAS band. Maybe we should essentially start running experiments, cranking up power, and trying to push those limits and trying to see what happens. And right, that you need that kind of trusted environment among everyone to willing to undergo that in a structured manner. But I think just that's not, that's from his perspective how he's looking at it. But that same idea is, I think, it's also valid from some of the other perspectives the panelists brought, because really what you're saying is we want to collect real world data, right? He phrased it kind of in a risk, like let's essentially run experiments and let's push the limits until we see interference. But that's really no difference in saying, okay, we have something deployed, let's collect real world data, let's run controlled experiments on a live system to gather that information. I think there's an opportunity to do those in real time, set up a nice structured, understand what you're collecting and gather that information and use it as a feedback when we start to improve modeling and improve approaches. I really think there's an opportunity to do that. Of course, you need that kind of foundation to get to that point, that collaborative environment there. And then lastly, really one of the things that, and this is no surprise to anyone, that really was an undercurrent to all of this, is these are hard problems. They take time. Eric, when he started talking, you start with likely a conservative type approach and you iterate it, but you have to allow time. So whether that's time before we actually get to auctions and deployment to work on some of these problems, to set a foundation, that's ideal. But there's no way you really can't compress this and expect to have optimize your results at the end. It just takes time. Whether you're collecting measurements, long-term data as to the deployment, you need to allow the process. And I know that can be frustrating to certain parties that are involved in these things, but that's just what is required to some extent. Or else you need to understand what the trade-offs are to not allowing that. So that's probably, I'll stop there. Thanks.
Yeah, no, great. No, thank you. Really appreciate it. And then, for this initial part, Doug, I'm turning to you, and I think the panel's probably fresh in folks' mind the most, but, sort of some technical enabler session. Thanks.
Thank you, Derek. Sorry, they're cutting grass outside. I hope it's not too loud in the background. So I first want to thank Mike Cotton and John Chapin for sending me notes. I haven't really gotten the time to think about what I heard over the last hour and a half of my session, but I have some notes and I have some thoughts about it. So I'm hoping you all got to attend the last session. What we were really focused on is, how can we innovate in the hardware and the software and the systems and then the data to improve spectrum management to make a more dynamic system. And I love the problem. I love the area. And the best part of it is that there's so much happening technology-wise. And we just took a cut across a couple of different areas because we couldn't represent the whole space of technology spectrum innovation. We had Charlie Bayless, who looked at reconfigurable front ends and what you could do at the antenna element. And this is one of these really critical areas, obviously, in the radio chain, what you could do to improve EMI interference mitigation. We had Shannon Blunt talk about software-defined radars and more controllable radars and what can happen in that space. We had David Jackson talk about a couple of active EMI cancellation techniques, of which there are many others to be considered. We also had Tommaso Malodia talk about system optimization and how do you then use control data that you could be extracting and sharing. And then lastly, we had John Cousins from Qualcomm talk about the kind of the more synchronous access in both licensed and unlicensed. And you can just see by cutting across those that these are all at very, very different levels in terms of the radio stack, in terms of the system, in terms of data intensive. And it just highlights kind of this opportunity. But then we quickly kind of talked about, and we pivoted and quickly talked about what are some of the challenges in this space. And I think, we heard it from the other chairs of the panel just in the last half an hour, that, it's a hard space to move in, and it's a complex space to move in. So we had asked the one question, and I think I'd like to start here, which is, what shouldn't we be doing? And to start with a double negative, it was, we shouldn't not be doing nothing. Or it's a triple negative. We got to do stuff. We got to get moving, and we shouldn't be doing this theoretically, at least not entirely. We should be really thinking about how to pull this into physically meaningful representations, how to do test beds, how to think about moving toward a national spectrum strategy. And I think this is a really critical point that was brought up in the questions. And I think that this realization that solving each of these things in these little silos, as we've been trying, improves each of those little silos or the adjacency to the silos. But this is a much, much, much bigger problem, and so rich from a technology and data perspective. The other thing that was stressed on during the what not to do is, moving away from that, what was the term? Not in my backyard. Interference, absolute interference protections, right? Which, I think 20, 30 years ago, that was a stronger assumption. We've moved the needle on that. There's still kind of a challenge there. And I think that this then gets into the issue of trust. And ultimately, anything that we do in the technology space, anything that gets integrated into the policy space, has to be built on some meaningful trust framework. And that's going to be, one of those ones why I do believe we need to have a lot of experimentation, a lot of test beds, and a strategy to integrate this so that it can be believed and be accepted. So we had a nice discussion also about, what's the biggest bang? What could we do quickly? And a couple of themes came out of that, which was we really need to start thinking about that integration from hardware to software to policy. How do we get that pipeline connected? And how do we feed that with data? And how do we feed that with data, the right data to solve the right kind of problems? And that kind of also went to that whole issue of, what do we do moving forward, and how do we start thinking about this from a coordinated perspective? And one of the things that came out was if we agreed on different paradigms of use and we agreed on different approaches from technology perspective, we could do much better cross-collaborative research. And NSF is trying to encourage this, but I think it has to be at a much, much bigger scale. And we heard hints along those lines. I'm going to try to look down at my notes as I'm talking. I apologize. There were a couple of little nuggets that I thought were really important. Shannon Blunt talked about the evolution of radars, that we shouldn't be thinking that radars are going to look like what they look like now or what they looked like 10 years ago, that they might evolve in terms of their operation in the spectrum band. And however this plays out, the radar side, the interference mitigation tools, as well as the comms or any other kind of device, that this is going to be an intensely computational problem, and that we're going to need to be thinking about that as we start ramping up into this kind of new paradigm. Any of the assumptions that we've made about how things are operating, we should probably really pull back from that, whether it's power levels of any kind of service, whether it's protection levels, whether it's the legacy devices. We need to start rethinking that as we move on into kind of operational modes for dynamic spectrum management. Some of the other things that I thought were interesting that came out had to do more with this kind of idea of add-ons in the spectrum policy space as we get this new technology. How do we incorporate that in? And John Kozma said that, or described models where we really need to start building in assumptions about the device and about the operation and other such things, which JP would agree. We've had many conversations about this over the last 20 years. But it gets to this idea that, the policy probably is going to look different as we get more dynamic, much more dynamic spectrum devices. We should expect that the policy needs to really evolve and be a much different looking beast than it has been for the last 100 years. And while that wasn't said explicitly in the panel, it was certainly implied a whole bunch of different times by all the panelists that it's going to be a new world. And I think that's the theme of this whole ISART this year, which is how do we move to a more dynamic spectrum paradigm. And I'll close with that. Thank you.
No, Doug, that's great. In fact, I think some of the things you said kind of set up as a nice transition to kind of, part two of the panel here. I want to take a quick moment to let participants know we're going to open up a poll here. So hopefully folks can participate there. Really looking at kind of two questions there on an iterative regulatory process on whether, you think it's beneficial, and then whether that is risky or not. So again, if you have a chance to take a look at that would be great. And then, so going back to the panel and building on what Doug said there, again, because I think you did sort of talk about that the answer is we can't do anything. We can't do nothing, right? We need to take some steps. And, the challenge here, and also the silos, right? In a way, a lot of these panel sessions are siloed themselves. And this is an opportunity to kind of, I think, have a discussion, bring some of this together. So if we think sort of 10 years out and where we may be evolving to, or maybe even more importantly, where we hope to evolve, right? I mean, we all can't, I think if we knew exactly what it would look like in 10 years, if you had the money, you could make some investments, right? But no, I think it's kind of where we want to go, where we could go, and then what are some aspects of our ecosystem or our processes, frankly, that we should get a jump start on. And I mean this collectively for the ecosystem, but frankly, for the spectrum regulators and policymakers too, right? Because at the end of the day, we need to enable this, right? And we need to do it collectively. So this is kind of the sort of, as you said there, Doug, the challenge of the ISART and why this was teed up. And now we're kind of have a chance to maybe think about a little bit of a roadmap, if you will. And again, I know we can't address everything, but maybe some key thoughts or points that folks have. And I guess for simplicity, I'll just go back to the original order, Eric, maybe, and turn to you first for your thoughts. And then and again, I also, if folks want to build off what someone else says or ask them a question, of course, do that as well too. Thanks. Eric, you gotta come off mute.
I don't remember hitting that button. Sorry about that. Yeah, thank you. Kind of going back to a comment Billy made, I think to look forward 10 years, we really have to kind of start with rulemaking and go backwards. And one of the things that's been kind of a constant part of discussion is folks at ITS have kind of kicked around, what's worked over the years. There are things that we know take time. They're Billy's in the propagation space, and he'll tell you it takes a good 3 to 5 years to put together a good model to get the data, develop the model, to validate it, and then to get stakeholder acceptance of it. And so if you need that model, you really need to start laying the foundation to get those building blocks in place. Propagation is probably the longest pole in the tent, but the EMC models as well. There's a plethora of models in the AWS-3 band. I think I counted at one point like 8 different models for exactly the same thing. And really none of them had been validated. And I have to really highlight the work that DISA DSO did with their spectrum sharing test and demonstration program is, we had proposed the idea of, what are some experiments that could be done to validate those models. And we used AWS-1 as a proxy, the adjacent band. And so now we have that experience. We we can look at other bands that are similar in nature and technology and maybe derive experience from them. But we also know that it takes a year or two to pull together, a framework. And each time we do this, we should be building validation in. We should be building in standardization, not just the propagation models, but also standardization of the EMC models. Really need to drive toward a kind of a common framework of modeling tools. I think as you go through all the discussions, each band has its own particular needs and incumbencies. You go back to the risk-informed assessment. Those key parameters are going to vary from one incumbent type to the next. And we shouldn't forget as well, I mean, for spectrum sharing, we need to be looking at the commercial side. What is the impact of the incumbent on the commercial receiver? And that's work that that Hill Air Force Base project that DoD is running is saying, what effect will the commercial system have on the DoD radars, but vice versa. Radars put out a lot of power, so we want to also understand that. So I think with each one of these, we're gaining additional knowledge. We are with time gaining confidence in various building blocks, and we're getting a better understanding of how long it takes to develop them. We really have to kind of lay those all out on a Gantt chart, right? And say, well, if this takes 3 years, let's get started now. Let's get the resources that we need, make the argument to the appropriators, get those resources, get that research started. And it's not just something that ITS does, National Science Foundation, industry. This is a joint research effort. This is, these models ultimately have to have stakeholder, acceptance, and the agencies need to be at the table developing them as well. But, we've got the tools and a lot of experience here in the last 10 years to really take a look back and figure out, where we stand, and how we can keep drilling down and improving the toolkits and getting them standardized and getting them accepted and making them available for everyone to use, which is going to speed this process up. And that's ultimately what we're trying to accomplish.
Thank you, Eric. No, that's good. I mean, you kind of hit on, I think, one of the fundamental challenges, right, where we want to standardize these processes as much as we can, while at the same time you have the variables with particular bands, and trying to minimize what those variables are will help provide some of that ongoing consistency. But really good points there. Giulia, I'll turn to you next for some thoughts on this sort of future-looking question. Thanks.
Thanks, Derek. That's a very good question. And I think I would like to sort of just amplify the concept that, to the extent we want to be thinking future several years, particularly when we're thinking about any federal agency, one of the important issues will be funding, right? And so certainly that is an aspect, and I think that's one, turning to our panel, that Edgar Rivas raised. But I think some sort of funding streams, and we know where the funding comes from in DC, would be very helpful to enable the sort of future-looking research that I think we need to be taking these more sort of iterative approaches and independent, individual steps. So, but looking at our panel, I mean, I will say one of the major takeaways, more broadly, I think from my experience, has been that you've got to start thinking pretty specifically before you can really start to implement something. So I think sort of looking for where are the opportunities to make this happen in the future, where are the bands? I think that's going to be an important question looking down the line. And I think from the sort of thinking about the more economic perspective, by the time we get to the economics and the auctions and how to assign it, we're really thinking about a band. So coming up with some applications, I think, would be very helpful. But I think all of these baby steps, right, as the getting better research, putting together, having sort of agreed upon models of interference, all of these pieces will become important. And then, thinking about the economics, I don't think we can lose. I think we need to think hard about kind of how do we keep the value of the spectrum? As we're thinking through applications, recognizing that whenever, that uncertainty, particularly in certain contexts, can alter the value of the spectrum, and thinking about how can we continue to create sufficient certainty and understand better from industry where they need certainty and from the agencies where they need certainty to find that middle ground, where there might be room for more of an iterative approach. I think I'm going to stop there.
Yeah, no, that's great, Giulia. I really appreciate the response. Ed, I'll turn to you next.
Thank you, Derek. And I think my experience in policy is that we're always very reactionary to the next thing that we need to work on. And often that means that the data collection is very reactionary. So, we need to make a decision in government. We need to go out and get some data if we don't have it. And that means we need to go out to operators and maybe ask for the data. And we need to get that in some sort of standard way that is probably hopefully anonymous and also allows you to aggregate it together. I think that there is something exciting in here, if there isn't already some sort of framework to do this, where we can hopefully capture more of this data because of the ongoing virtualization of the infrastructure. And I think just picking up on the point that Doug made about moving towards an iterative regulatory process, in my eyes, that means potentially integrating more real-time data, because you're going to have the data in real time. There's this whole area now called nowcasting, where you're integrating multimodal data. So we see this in economics. We've done shipping data. I've done work using satellite data to estimate mobile users spatially. And because there's such amazing new dimensions to all of these data sources, we're getting spatiotemporal imagery of multiple revisitation rates per day. There's all these new types of data, and we could combine that with other spectrum data that we're also able to get stored in the cloud. So I think that there's a lot of scope to be had here if we can work out, if researchers can work out how the pieces of the puzzle fit together, essentially, so that ultimately we can get meaning from all these different data sources. That's an exciting challenge for researchers, but I think also my experience in government would be that there'll be beneficial outcomes from having evidence on spectrum usage across time, space, and bands, and things like this, because I don't see that currently in play at the moment. So over to you, Derek. Thank you.
Thank you. Great. No, I appreciate that. And JP, I'm going to turn to you in a second here. I'll add into the mix here a question that came in from a participant on, do we need a new PCAST report? As you're thinking that comes up, I thought about that. I can't believe it's been a decade. So that was actually 2012. And, obviously that report, for folks who remembered, had some really good impacts, including, I think, being some of the key thinking for CBRS even. So, if folks can want to put that in the back of their minds too, as they're responding here. But JP, I'll turn to you. Thanks.
Thank you. Yeah. So, the question of what things going to look like in 10 years, the cynical answer is pretty much like they look today. Because, actually, I'm spending time on the FCC's receivers notice of inquiry. The last one they did was 2003, which is 20 years ago, near as damn it. So the glass half full view, though, and I guess I feel optimistic, is that something does seem to be shifting. But, then one doesn't get up in the morning unless you believe that. There are three things that I think, looking forward, came out of the panel for me. The one is how we spread know-how. The second is how we create places to resolve differences. And the third is a thought about thinking about risk management when we think about iteration. So to the first point, one of the things that was very clear in the panel, you asked the obvious question. So what is risk analysis? How do you do it? Give me an example. And the answer is there are lots of ways of doing it. And it depends on the circumstances. It depends on the problem. It depends on the stakeholders. It depends on many things. But there are people who do this. And so I think one of the things that I hope will happen, particularly in risk analysis, but other fields too, over the next, let's say, 5 years, is that we actually spread the knowledge. There are other industries and regulated industries that have been doing risk assessment for 40 years. So there's a lot of know-how that we can benefit from. There are also experts in our field, many of which, were on the panel, people like Omar Alcala and Nick Lasort and Rob Henry and Kelly Codson, who are doing risk analysis for Spectrum today, but so far they're the leading edge. So the question is, how do we actually spread the know-how? One of the things that occurred to me, looking at ISART every year, these wonderful tutorials. And so maybe there should be an ITS institute, which actually will pick, a theme for a year and actually run lectures, curriculum. Actually, if you want to do risk analysis, just go and look on the people who spoke on the panel. There's your faculty. And put together a way for the community to get educated and then to share experiences. Then the second point I wanted to make, and this was about resolving differences. This is an idea that Kumar Balachandran raised, is, obviously when one does risk assessment or coexistence in general, different people interpret the results of their studies differently, and it takes time to resolve that. Within a particular industry. So for example, within 3GPP, there are long arguments that go on a lot of, people bring their models, they differ. In the end, maybe you sort of like pick a number in the middle somewhere. It's much harder when we're talking about different industries. There aren't standards bodies that I know of that really cross communication and aviation, for example, or communications and radar, communications and or radar and Earth observation science. Every country is different, every region is different. The Europeans, though, have a mechanism that has worked in some cases. They have the European Communications Committee, ECC, that brings together people. They do studies. In Europe, they have ETSI, the European, what does it stand for? European Technical Standards Institute, which is actually supported by the European Commission, but it's not a European Union thing, but it's a place where everybody can come together and develop standards. So the question going forward is, where do those kinds of conversations happen in the US? There are places where they do happen. CSPAC, Common Spectrum Management Advisory Committee, is one place. But a related question, this came up in our panel several times, is this takes resources. It came up today as well. People have to invest a lot of time. And so it's not something, to some extent, we try and get things for free. We get the Technological Advisory Council, bunch of volunteers, CSMAC, bunch of volunteers. Do we have secretariats to really support them? How do we do this going forward? The third point I wanted to make was to talk about risk management, which is something that the panel didn't really get into. It was one of the many topics we only touched on. But we talked about risk assessment, which is what you do beforehand. Then once you have a deployment, you need to keep managing the risk because stuff will happen and stuff will change. And the philosophy of risk management, I think, is something we can learn from. It also links in with the whole question of enforcement and remediation. Things will change. They get better. Sometimes they get worse. We had examples of both. And so how do you accommodate those? One speculation, one way you might think about having more flexible rules. Obviously, you don't want to give the FCC the ability to say, we've changed our mind. Rules have just changed. But you might be able to do some of that at least through a risk management process, or perhaps even through an enforcement process.
Thank you. No, that's great. Interesting. I'm going to keep it rolling here, Billy, to you. Thanks.
Yes, thanks. I think the one thing that Kepron touched on, and that has been proven in the past, has shown, is really the idea of openness. And I would even press farther to perhaps how our panelists say it. They talked many times openness between the organizations working the problem. I would even venture to some extent to go even farther out on the limb and say even openness to the public, right? So, Chris Crescencio of the FCC talked about, he got his start working with Bertoni, and some of the work that was around, was overbuilding diffraction and stuff decades ago. It was, it's a good idea. And then you had this idea, you have this theory being developed, and now only in the past 5 years, maybe, you have essentially coming into a world of people sharing for free ubiquitous LiDAR data. And now you have the information of where buildings are in vegetation. And so now you have this theory that was being developed, people sharing in a different field, the information is open. And now he talked about how, the FCC was working on modeling, applying this to this sort of data, right? And so you can get, the more open we are, and that open isn't just at the end of the process publishing the final model, the final standard in some 3GPP or study group 3 recommendation, but incrementally in those steps, publishing and being open, both with your measurement data and your validation sets and the modeling approaches, even if they're not complete, but the progress being made, I think, is important, because you both can get a cross-pollination of different fields, right? Like, we're very specialized, but engineers, you talk to them and it breaks the stereotype a little bit, but when you really talk to them, there's a lot of creativity and a lot of ideas. And they're like, well, if I only had this from over here or this from over here. And I think really a lot of improvements are going to become some of that cross-pollination of different fields, not just propagation. You have to look at the bigger picture. And we're sharing data, other people are sharing data, and I think that's going to facilitate a lot of new ideas and new ways to approach problems and solve them. And that's really going to be critical. And then by putting it all out there ourselves, like I said, even incrementally, allows people like Dr. Salus, who are in universities, or I didn't see the panel before this one, but I know there's a bunch of people in universities, them to essentially come in unbiased and take a look at this data and run their own analysis, run their own simulations on this and give feedback. Now, when you are open, you introduce noise into the system, and that's a risk we just have to manage. But there's a lot of upside benefits to doing that thing. I think, we are moving slowly in that direction, but I really think that's going to really help us make some gains into this kind of iterative process.
Thank you. No, that's great. I'll note we're a little under 10 minutes here left. So Doug, I'm going to give you a chance to kind of bring us home here, and then, but I will give everybody a 30-second lightning round if they want to make final comments. But to you, Doug.
Thanks, Derek. I hope my audio is doing better. I apologize for that. I want to start with the other question that came in, the PCAST report. Yes, I think it's time for a new PCAST report, and I'll explain why. We had the National Broadband Plan that had a kind of a heavily licensed view of spectrum and moving that ahead. And then we had PCAST, which was a very different view. I think it's time to set this kind of national strategy, and these types of reports are perfect for it. They get the ball rolling. They almost never live up to their potential. They almost never cover all of the things that you want that comes out of them. But at the very least, it goes to that point that was raised before, which is we have a very distributed set of entities working in a very distributed silos. We have research that's funded, but in a non-coordinated manner. We have opposing interests. So we need something to kind of set the tone. If we're going to say we're moving toward a more iterative and a more dynamic spectrum management policy, we're going to have to kind of start and say, well, what do we mean by that? And I think that kind of report, a national report, could do that. Then I think from a technology perspective, I mean, this is a hard nut to crack, right? Which is, as technologists, we dig in and try to solve problems, and they might be problems that have, small impact. It might be a problem that has a huge impact. So we need to understand, where in the bands and what should we be doing and what technical problems should we be solving, and really invest kind of nationally in that so that we can build, understanding of risk and improve trust and do all the other things. But we need to start it now so that when time comes for, whether it's, gigahertz spectrum or reallocation of lower bands or whatever it might be, that we have some meaningful data and something to have some faith in. But I don't think we're going to be able to do any of these sorts of things without sort of a framework at a national level to say, let's start moving ahead. And these are the challenges. These are the opportunities. Let's pick a few of them. We'll get DoD and NSF and others to coordinate. Use ITS as a mechanism as well to try to say, hey, we got great technology. Where does this fit in? And we know that we're underutilizing the spectrum. Let's change that.
Awesome, great, thank you. Yeah, the issue of coordination just has me thinking too. I know it's come up a little bit, but at NTIA and with the administration, we really are going to try to produce a national spectrum strategy. And it's been elusive and it's hard. And I think that's a key part. But I hear this as we want to break down these barriers and break things together. And we talk of R&D and spectrum sharing. So I know that's a hard task in front of us. I think the funding one is, again, to silos. We all have our individual funding requests and we go through the appropriations process. We have hearings. There's markups this week on the Hill, and we have our IIC. And, there's so many funding requirements. You're pulling from the SRF here. We've had this dream for years of how we put more money from spectrum auctions back actually into the, spectrum regulatory processes. And that's been a challenge, right? Because the, Capitol Hill wants money for other things, including deficit reduction, right? So a lot there. And, the other one I think of is talent, right? I mean, we all of us participate in some of these events and really working on trying to bring in the next generation, the younger generation of expertise. And we need a lot of it. And we need a lot of it in a lot of different places. So I want to thank everyone, unless anyone has a quick little comment they want to make. I think Giulia is waving her hand, maybe.
Thanks, Derek. I should say this is sort of a follow-up to Pierre and Doug's points. I think actually one of the things that came up on our panel, which I actually really liked as a proposal, and was Carolyn Kahn talked about using an agile approach to spectrum management. And I think that concept is neat, particularly because us in the government knows what it means. but that almost in many ways provides like a framework within which to have this conversation, right? And an answer to like, how do we do this quick, how do we create an iterative approach? And I think it was highly insightful for her to have thought about that. And I just want to highlight that when we're thinking about, what's the process or what's the framework that we put in something that's iterative, the agile process actually works nicely.
Yeah, no, great point. Yeah, great. Anybody else?
Yeah, just to pick up on that point about agile, it's an interesting one. We'll have lots of scrums. Actually, since one of my traditions is to always disagree with Doug, no matter what he says, no matter how good his ideas are. Let me say that we don't need another PCAST report. Actually, we do. But for the sake of argument, what these reports give us is feast and famine. Right, we have this big strategy, and then there's 10 years passes, and then there's nothing, and then oh my God, we've got another strategy. I think what would be much more helpful is what Giulia just said, which is to have a process where we get together not every 2 weeks, but whatever, where we actually iteratively have a set of plans that get updated every year. Now that takes a lot of work and it takes a lot of time, and where's the money going to come from? But I think that would be much more useful in the long run than doing something big every 10 or 20 years.
I stand corrected as always with JP. So.
No, that's great. In our conversations on a strategy, we actually agree in the sense that it's really the implementation plan and the implementation that's more important than the strategy itself, right? Because if you produce a nice strategy and it sits on a shelf, you have to actually implement.
So again, the value of the PCAST reports or any of these sorts of things is it's a top-down sort of thing. Everyone kind of looks at it, and everyone and you can cross agencies. That's real, but I agree. I think Giulia's approach is right too. Or I also like the term agile far better than iterative. As a computer scientist, iterative means to a point of an end. You do it to it. So iterative doesn't work for me, but agile, I like that. I like that kind of perspective.
Awesome. Thank you. Well, I know we are out of time, so I'm going to have to wrap here. I did want to say we did put the poll out there on whether this iterative process, would be, 55% say it would be beneficial. At the same time, 56% also say it's a little risky. So it'll be interesting. But I want to thank all the panelists. This was a great conversation, a great wrap up. I think we do have a final wrap up coming here, but thank you everyone, and enjoy the rest of the day.